Memory. It's a word we use constantly, right? But what is it, really? Is it that mental photo album in our minds, or maybe the silent chips inside our computers? Today, we're doing a deep dive into how memory works in both humans and machines, and crucially, how the, well, explosive rise of AI is radically reshaping how we understand both. Our mission. To unpack that silent struggle inside your computer, look at a famous human memory case that changed science, and then explore how AI is, get this, literally creating memories that never even happened. So, okay, let's start with the computers. Memory inside our machines. How much has it really evolved?
Oh, it's astonishing, the scale of change. I mean, think back to the original IBM PC, 1981. It had just 16 kilobytes of DRAM, that's dynamic random access memory, and an Intel 8088 chip with like 29,000 transistors.
15 kilobytes, that's tiny.
Exactly. Now, a modern PC, pretty standard, has at least 4 gigabytes of DRAM, and say an Intel Core i5, 559 million transistors.
Wow. Okay, that's a truly massive leap. It makes you realize, what we just take for granted today, streaming video, complex software, that was science fiction back then.
Yeah.
But I've heard there's this constant battle, right, between processor speed and memory speed. CPU speeds have rocketed up.
Oh, absolutely. Over 760-fold increase for CPUs, memory designers.
Yeah.
Well, they've really struggled to keep pace. It's a huge bottleneck. So to manage this speed gap and different needs, PCs use a hierarchy, different types of memory.
A hierarchy, like levels.
Precisely. You've got the massive, slower, but non-volatile hard drives way at the bottom for long-term storage, archival stuff. Then faster but volatile DRAM, that's your main working memory. It needs constant refreshing, like a leaky balloon, basically. If the power goes off, it's gone.
Okay, so volatile. Got it.
Exactly. Then there's even faster but more expensive SRAM static RAM, often used for cache memory right near the CPU. And of course, non-volatile flash memory for things like your boot up instructions, stuff that needs to stick around. Each level plays a critical role.
That's fascinating. So many layers working together. But this whole idea of storing data, it makes you think about our own minds. Let's pivot a bit. Human memory. Is it really anything like a computer's? Or is that just, a handy but maybe misleading analogy?
That's a really profound question. We use those computer analogies all the time, but our biological brains, they work profoundly differently. Consider the famous case of HM. You might have heard of him. A patient who had surgery removed parts of his hippocampi to treat epilepsy.
Right, I remember reading about that. Tragic case.
Terribly tragic. After the surgery, he completely lost the ability to form new long-term memories. He could remember his past, up to the surgery.
Nothing after.
Nothing consciously, long-term. He couldn't learn new faces, remember conversations from minutes earlier. He was essentially trapped in the present, anchored to his past. But this case, as sad as it was, offered revolutionary insights. It showed us memory isn't just one thing. It involves complex processes, encoding information, storing it, retrieving it, and different brain parts are involved. It really highlighted how fundamental memory is to our identity, our ability to learn, to adapt. It's who we are, in a way.
Yeah, the HM case is chilling. It makes you realize just how fragile that sense of self tied to our timeline really is. And this is where things get really interesting now, with AI entering the picture. How does AI fit into this landscape? You hear about it blurring the lines between human and machine. What does that mean for memory?
Well, connecting this to the bigger picture, generative AI, it's truly altering our very concept of memory. It's not just about storage anymore. Some researchers say it can, quote, untether the human past from the present. How? By producing a past that was never encoded into memory.
Creating memories that never happened.
Essentially, yes. Generating text, images, even video that looks and feels like a record of the past, but it's entirely synthetic. It never actually occurred.
Wow.
And think about the idea of a conversational past. AI enables simulated dialogues. You could potentially talk to a chatbot version of someone who's passed away.
Like a digital ghost based on their data.
Sort of. It's accessing and reconfiguring information in a way that simulates memory and interaction. It's this dynamic entanglement, human-machine data. It's leading to what some are calling a third way of memory. And not just biological, not just digital storage, but something new, interactive, synthetic.
Okay, that's a mind-bending concept. A third way of memory. So how does this translate down to the hardware? All these new AI PCs, everyone's talking about how is memory actually impacting their performance. It's happening under the hood.
Right, so AI PCs, they have what's called a heterogeneous compute architecture, fancy term, but it just means they combine different types of processors. You've got your standard CPU, an integrated GPU for graphics, and crucially, a dedicated NPU, a neural processing unit specifically for AI tasks.
Okay, specialized chips working together.
Exactly. And for all that local AI processing running models directly on your device, not just in the cloud, they rely heavily on optimized memory. We're seeing tests, for instance, showing dual-channel DDR5 memory that's a newer type of RAM can deliver like 20% faster AI performance compared to older single-channel setups.
So the memory setup directly impacts how fast the AI runs locally.
Definitely. And what's maybe even more compelling is power efficiency. Newer memory solutions, like something called LPCAM M2, they're showing massively reduced power consumption. Maybe 85% less power than standard DDR5 for certain AI tasks.
85% less power. That's huge for laptops and battery life.
It's a potential game changer. Better performance, much better efficiency. It enables more powerful AI on the device itself.
So wrapping this up, what does this all mean for you listening? We've journeyed from the explosive growth of computer memory to the deep complexities of human memory via HM, and now into this wild new territory where AI is literally redefining memory itself.
Yeah, and it brings up a really interesting question, doesn't it? As AI makes computing, and maybe even thinking, more efficient, will our demand for its capabilities just keep growing and growing? Could we see something like Jevons paradox?
Where increased efficiency leads to more consumption, not less.
Exactly. Greater efficiency paradoxically driving greater overall demand. It's something to really ponder, I think, especially as we think about the future of intelligence, both artificial and human, and the memory in all its forms. That makes it all possible.